All right, folks, for this episode of AI in Construction, I'm here with Chaitanya NK of Track3D. He's the co-founder and CEO. We're going to talk about progress tracking, machine vision. There's been a lot of this. This has been going on for a while, and it's, of course, the underlying technology keeps getting better all the time. We're going to talk about how it actually works under the hood. We'll use his product, but a lot of this is just trying to understand how AI can be used for this. And the other thing that Will NK and I are going to talk about that I'm really excited about is changing the way we position some of these tools so that we're not saying it does 100% of something like, Excel. You give it all of the numbers and it's going to give you every time 100% of what you want. You don't have to get in there and do math yourself. But the reality is AI is taking a messy world and doing things for you. And what we'll also talk about, it'll do some things that no human would ever do. So it opens up new possibilities, but we need to be realistic about what it can do in a messy world. So it saves a ton of time. It opens up new possibilities. So today we're going to get through that in a lot more detail. Okay, welcome to the podcast.
Thank you. Great to be here.
Yeah, well, let's talk. I kind of gave a lot of it away, but I wanted folks to know what we're on about. Talk a little bit about how progress tracking works and kind of the progress that is, no pun intended, that has happened because people have been trying to do this for a little while, but again, the tech has just gotten better, the AI has gotten better. You're kind of a new generation of companies doing this. Tell me about what you guys do and about how the AI makes lives a little easier.
Perfect, you. And just to give everyone a bit of a context, right? Let me tell you what we are doing here at Track3D. So as you rightly said, Track3D is a reality intelligence platform. That's what we call it. And reality capture intelligence is nothing but artificial intelligence combined with reality capture. So reality capture, as you traditionally know, is capturing site conditions using a 360 camera, mobile phone, drones, laser scanners, or whatever visual sensors possible. Now, reality intelligence is how do you convert the data that you have already captured into meaningful insights? Now, what could those insights be with regards to a job site, right? There are two things mainly that Track3D is focused upon. We have the quantitative as well as the qualitative aspects. Quantitative is telling you the progress, in fact, telling you, hey, 50 linear feet of duct on level 4 is installed. That is the quantitative progress. Qualitative progress is telling you, hey, as per the design, this is 6 inches off from where it's supposed to be installed. Or, there is a crack that we have observed. So this is what Track3D specializes in, both quantitative as well as the qualitative aspects of progress monitoring of any job sites, and using the same data that sites have been capturing all through. So it doesn't change much in their workflow, but adds so much more value.
Well, one of the things let's talk about the qualitative for a sec, because I wasn't aware of that, and I love that. There's an interesting question, and that is, are you now able to say the site is good? Or is it more saying, hey, we found some things, go look for them? Like there's a real difference between saying that the AI could ever, or actually anything going through a camera, could ever be 100% catching everything. And I think that's where in the past people have maybe gotten a little caught up, is they're frustrated that it didn't catch everything. And the problem is nothing that goes through a video camera that isn't purposely being driven over there to go see the thing could catch everything. So you're saying, no, what we're going to do is flag things for you. So you'll catch them. Maybe you wouldn't have before, maybe you would have, but now you have them. Is that how you position this? Is again, not 100%, but it's doing things for you. So you know what to prioritize and you can get out there and go look yourself.
Absolutely, you. Now, the way we position Track3D is if you can see it, we can track it. That means that, any visually distinguishable element, it can automatically quantify and qualify for you. But as you rightly mentioned, there's so many elements which might not be visually distinguishable, like two coats of paint, or say a ductwork which is installed, but the commissioning has to be done. The QC has to be done for it to be set complete. Now, these are manual tasks that no camera can actually catch. But we looked at it differently. The way we looked at it at Track3D is, hey, this is data that you're already capturing, but you're doing nothing with it. It's only acting as insurance primarily, right? If something goes back, we go and have a look at it just so that we have evidence. But we thought, can we leverage the data that you're are already collecting into providing some insights. Now, if you start thinking about it that way, right, you would unlock a lot of value with that data. Because to our point that you were initially mentioning as well, it's humanly impossible to measure everything that is being installed on a site on a daily basis. There are thousands of studs, frames, wires, ducts, conduits, so many elements. And to measure everything, in spite of the labor crisis that we currently have, is almost humanly impossible. So that is where AI can truly, truly shine. It can do all this, hard menial tasks and do it very, very simple with the same data that you're collecting.
Well,
That is the way.
go ahead. You talk about the data that already is being collected. One of the questions I'd have then is, is your system able to say your security cameras we can only do this with those cameras because they're too low res or they're too far away? Doesn't mean you can do nothing, but do you like kind of gate it and say, look, we can tell you big things like drywall was installed, but you really need to go look or point a camera closer or put it on someone's head or whatever it is.
That is true, the quality of the output obviously depends on the quality of the input.
Right.
Different sensors have different resolutions, right? Say you need the 1 millimeter level resolution to do a slab flatness. For that, you would obviously use a laser scan. That is the camera that will give you, or the sensor that will give you that level of precision. Whereas you want to see, hey, how much of ductwork is installed on my level? For that, a normal 360 or a mobile camera would do. So where you get about half an inch to 1 inch levels of accuracies. So your level of accuracy truly depends on the sensor, and it's about using the right tool for the right job.
Right.
But our purpose was, can we take use of all of them together and extract whatever meaningful insight we can?
And yeah, so the answer is kind of yes, is that your system is good enough to say, it looks like I've got 1 inch, so here's what we can get for you. And if you want more, as I say, there's a limit to what visual cameras can do. I love that you also include laser scans and other means of reality capture. That's really interesting because to your point, you can do insane things with lasers. Um, really cool. How do you orient? So one of the concerns is you're going off of a BIM model, you're going off of a drawing for it to say something is 6 inches off, you need to know against what. Do you use total stations? What do you use to orient or understand, how to think about a measurement?
Right. So when you talk about measurements, right, there are two things that you can actually mention over there. You have the absolute accuracy as well as the relative accuracy.
Hmm.
Now, absolute accuracy is your scale true to, ground conditions actually. But what we focus on in Track3D, at least initially, is the relative accuracy part. That is, any data that we capture, be it drones or 360 cameras combined with mobile, we make sure that it comes to the half inch to 1 inch levels of relative accuracy. That is, any measurement you make on the virtual 3D model that we reconstruct, you would get to that level of accuracies.
Yeah.
Now, one, yeah,
Go
sorry.
ahead. Please continue.
Yeah. And once you get to that level of accuracies, right, now you know what is installed and you have a reference in terms of design. So to tell whether, this has been actually, installed as per your specification, you have your 3D design as a reference. So for progress monitoring, you don't need any reference.
Hmm.
So, but whereas, for qualitative checking of everything, you would need a design reference, which could be a Revit or a Naviswork model. That is what is providing the reference to tell whether, you're on track or you're off by 6 inches or whatever.
Yeah, it makes sense. When you think about the types of trades that you can do with this, what do you find people use it the most for?
Right. So what we can currently track with Track3D, there are about 120 plus elements that we are already tracking. And these range from a wide variety of elements, from mechanical, electrical, plumbing, finishes, to even concrete, slab work, the whole wide variety of elements that we can track. And mainly there are our users range across general contractors, trade partners, as well as now owners who want to track everything that is happening on their job site. So they're using across a wide variety of use cases, the most prevalent being validation of a pay application,
Hmm.
like how much work was done during a certain amount of time. You would get exact quantitative measurements, which was almost impossible to get manually.
Well, speaking of what's impossible to get manually, what I mentioned earlier, one of the areas of AI that people are still we're still new at this, right? So we're still thinking I could do this, it can do I can do less of that because AI can do it for me. So the first thing people think about is replacing human activities. But what also happens is because it's so fast, because it's relatively cheap or really cheap depending on the thing, you might do a lot of something you wouldn't do before, or count a lot of something you wouldn't do before. Like you used an example of studs, I think, but like it can count things, and you know this now, whereas you wouldn't have known it before because you're not going to have someone who's making 80 grand a year go count little pieces of metal sticking out of a slab. Talk to me a little bit about and I would assume this is still early. I still would assume people are still figuring out quite what to do with this, but it sounds like there's new opportunities to understand your job that maybe wasn't true before.
100%, right? And I think the best way to explain this to you is actually show you some visuals around this.
All
Is
right.
it okay if I show you this?
Yeah, I'm going to switch over. So we're looking at the site or at your image. This is the product, as one can tell from the logo.
Yes. So this is Track3D, and right now we are looking at drone imagery. Now, drone imagery, first thing that happens is, although the system takes in only raw drone images, so you would see the green blips over here, right? Each one is an individual image taken from that perspective. But what the engine does really well is, it combines all this individual imagery together to form hyper realistic and accurate 3D model of the entire site. Now,
So
this is
it's building its own photogrammetry.
so it is not truly photogrammetry. It's a combination of SLAM photogrammetry and advanced visual renderings, actually. So it goes through a custom pipeline
Got it.
because I think photogrammetry has its flaws, right? It cannot recreate or reconstruct every object, especially narrow objects or thin objects or reflective surfaces. It struggles. So
I was
this is
just
a
excited to use the word photogrammetry, so I got that done today.
So that is one. But then, making everything measurable and in 3D now gives you a different perspective altogether. Because now I was talking about design and reality coexisting, right? Now this is a good example of that. So with one click, this I'm bringing the Revit model as well as the reality in the same virtual space together. So you can not only see what is installed, how much is installed, that the system will tell you by default, but now you can actually verify, hey, this air conditioning units that we see, are they installed to the right specifications at the right location or not as well? And if not, our deviation track module will automatically highlight that as well, saying that, hey, this is 6 inches off from where it's supposed to be installed. Now, that level of insights is almost very difficult to measure, right? Even if you have multiple people on site, multiple engineers, measuring everything to that level of granularity is super difficult. One more thing I wanted to just highlight over there, right? I'll show you one more very quick example. And this example is about how do we identify the different elements. Now you're seeing a video of an interiors of a site. This is a hospital project, and this is a robot dog walking on site. The top part is a raw video, but bottom is what our AI engine is actually converting it into. Now you see, as I play the frames, every individual element is identified, segmented by our AI engine as a unique way. That is what is allowing us to actually measure everything, irrespective of it being present in the design or not. For example, this particular project, the use case was, hey, you see this green elements, right? These are backing elements in the wall. The customer wanted it to be measured and tell which walls have it, which walls not do not have it. Now, these are not present in the design, not in the model. But as you can see in this image, right, the green, the system does a very good job of picking it up across every image and then quantify it and then show it simply in a floor plan. These are the level of insights that were previously totally not possible, and AI enables this.
And for that instance, did you have to train it or point it at this and say, look for things that are like this? Is that part of your offering? Is that you provide service alongside? I mean, sometimes they don't need to because it's maybe something you've done a lot before. But I think one of the areas also of AI, unlike other software where once you've trained somebody, anytime you're calling someone, it's because you don't know how to use a feature or something's broken. But with AI, very often to really take advantage of it, there has to be a service layer that comes alongside it. Do you find that that's true?
Absolutely, you. And I'll tell you how this works, right? Traditionally, machine learning models that you are referring to, you had to, like, say, you want to recognize cats and dogs from images. You had thousands of images, manually label cat and dog. Then you create a model out of them. And say, next, you want to identify a horse. You would again need thousands and thousands of horse images along with these two to create a model. Now, where AI excels at, it removes all those dependencies. And to show that again, right, I can show you a very quick example so that you get absolute clarity on how AI is being used over here. Now, this is what is happening in the background. Every image goes through this pipeline, and I've just given one image, and let's say a random object in this image, safety code. Now, machine learning models would require thousands and thousands of images manually labeled and everything. But AI first approach like this. I gave safety cone as a prompt, it identifies it, looks in the image, and automatically tells me there are three safety cones present in this image. Not only that, it would actually segment them properly. In fact, you see the one on the far left is actually partially visible. The system does a very good job of not only identifying it, segmenting it, counting it, and every image goes through this process. So that means now you don't need that level of manual training. So what this means to the customer is, or to our partners are, they get really accurate data, really fast, and really in a cost-effective way because all that manual training that you traditionally had to do now need not be done.
That's really interesting that there's a semantic layer. It's not quite a prompt because it's not what it is, but it's reading the English and looking for what that word means, and then searching presumably in a database of what's a safety cone. Okay, let's find things that look like a safety cone. Do you find that you're over time starting to get better and better at different types of products? I mean, that gets into a lot of data, and a lot of kind of a talk about a pipeline, but being able to identify different products that that get more and more specific. Is that there's got to be a limit to it. You said you have 120 or so items now. Is that one of the ways that you're continuing to grow? Is just getting more and more specific about this product, not that product?
Exactly. Now, there are some research facilities, medical gases, basically, pipes going through. Now, AI is becoming better and better in terms of automatically reading the labels
Oh,
or reading QR codes on
right.
top of that and telling, hey, this is supply air duct, this is a oxygen duct or oxygen pipe. So it's doing all of that automatically. And our agentic capabilities are even advancing it further, where it takes a copper wire, looks at it on the design, forms that association that hey, this copper wire corresponds to this element in the design, and then goes and tells, hey, I think you have not installed the right cable or right duct over here, or it's automatically off from where it's supposed to be. I mean, the future of where this is going is truly, truly exciting, and these kind of insights were almost impossible even an year back.
Right. Yeah, that's kind of why the service side of it is really interesting as well, is that as you get better, as it gets better, being able to use that well is going to be an important part of how you sort of make people understand how to use it. Um, Interesting. Um, when it comes to, going back to the quality of the image that you're using, do you sometimes say, hey, if we had a better image, we could find more of this? Like we've got X, but we could get X plus Y if you went and took another picture, or you just changed the way you're doing your reality capture. Is that some of it also? Is that like, okay, because people don't necessarily set things up for reality capture. I mean, obviously, if that's what they're doing, then it is. But a lot of what you're saying is you guys are sitting on a lot of data. Let's do something with it. We're going to move you this much forward. And then we can say, hey, if you invest in better reality capture, you can get more.
So the way we looked at it, you is, we really empathize with all the folks working on a field. There's
Yeah,
so much that they do, right? We don't want them to do additional work just for a software to work.
good point.
They should that the software is actually helping them with so much information that they were not able to do. It's making them more efficient.
Yeah.
Let's spend that 5 minutes extra on a capture. So that's the way we looked at the problem. We said, don't worry about uh, how you have to capture, how much time you have to spend, all of that. We'll first show you what we can get out of this data. Once they see that, and they believe that, hey, this is helping me so much, it saves so much of my time, they would spend that 5-10 minutes extra to actually make the captures even more efficient. And it's nothing special, right? It's just walking, but making sure that you have walked into every room. And to be fair, right, these are large, complex sites when you talk about an airport, a data center. Almost, it's not they missing something intentionally. They just don't know whether they have walked that area or not. So again, it became a product feedback for us. Can we give them real-time feedback, like how you drive on a Google map? Can we show them a path of how they're walking? And we bake that into our product. So we are learning, and the way we look at it is, this should serve the field. We took a field first mentality, and it should not be the other way around. They collect data so that the product works. The product is working for them.
What do you do about low Wi-Fi environments?
Oh, we do not require any connectivity at all here. So it's completely offline because some of our sites are in the remotest corners of US, of the world.
Right.
So we have to make sure it works. So you do not need internet or connectivity while doing the captures. Just to upload the data after you have collected data, that is when you would need it, and you can come back to your office or your trailer and do an upload from there.
Well, how about using the software itself, though? It's pretty high bandwidth. Does any of it happen on the machine, or is it so intensive that it has to be connected to Wi-Fi to work? Not again, not the capture, but looking at all of what you just showed me. It looks like the
Yeah.
sort of thing where having it run locally would be certainly a challenge in a tablet.
So that is true, and we are making an offline version as we speak. You even for viewing the data. Right now, you can partially view the data because it's just so much data, right? You have 3D, you have 2D, and all of that. But we are giving a lightweight version of the data so that you can view your progress information, because these are all lines on a floor plan. Now,
Yeah.
that's one thing about Track3D. You do not require design or 3D models for doing progress monitoring. So even a 20,000 square foot retail outlet. In fact, the smallest project that we have done is a residential renovation, 2,000 square feet residential renovation. And they just use the mobile to capture and track progress on top of that. So yes, it is there, but it is not there to the fullest extent, obviously because it's offline.
Yeah, that makes sense. Very interesting. And when you think about the initial onboarding, there's obviously you made it easy to use, but again, because you're offering things that they didn't have before, do you find that also there's almost stages where it's like, okay, we're going to spend 20 minutes showing you how to get started. And then when you're ready, let's have another one where we're going to actually introduce you to some new things we're finding because this is where again the service layer comes in that you get to share with them how other people are using it so they can get smarter and they can do things they couldn't do before.
Quote in a quick example over here, you. One of our customers does about 2,000 projects in a year. And their first question while onboarding us was, hey, 2,000 projects, if we have to bring onto a platform, it has to be easy and it cannot take weeks of time to onboard. So we again took that as a product decision. And now you can onboard any project on Track3D in like 15 minutes flat. The customer does it themselves, and we are there to support them in case they need us actually. So it's self-onboarding, minimal effort. All you need is set up the hierarchy and drawings. In fact, your drawings also could be connected with Autodesk or Procore wherever they exist. So have those integrations built in, onboard, get started. There's no training element as such required. People directly get it. People have been doing reality capture for quite some time. And
Yeah.
this makes it so easy actually. And that was very key to make it as simple as possible.
Yeah, that makes sense. I love this, and I love the fact that AI is starting to get more and more powerful in the real world and not just in text and voice. The model under the hood, we hear a lot about generative AI versus deep learning versus, other things. Is this primarily, it sounds like, I mean, usually when we look at things that are visual, computer vision, under the hood, it's deep vision, sorry, deep learning, machine, computer vision. Is that the primary driver? And then you've kind of connected it to, I mean, if it's taking in English, it doesn't have to be generative AI, but often that's a good layer just to clarify if somebody wrote it the wrong way or whatever. What is the sort of AI stack, for lack of a better word?
There's so many elements to it. It is not one that I can actually tell, and I'll give you examples of it as well, right? The first thing that I showed you, right, the 3D reconstruction, that itself has an AI process in it. So it's like photogrammetry. Yes, that is the core of it. That is the structure from motion part of it. But then the 3D visualizations that you see over there, that
Yeah.
is AI generated actually. Because it's images and point cloud acting in tandem to create a virtual 3D model that you can navigate around. That is part one. Then part two is how are we identifying, segmenting those elements in? I showed you the live example of the safety cones, right?
Yep.
That is AI. That is AI in perfect action because it is zero shot. It doesn't require any prior training. It's learning and acting on the fly.
Right.
Then also, how you retrieve the data also. There is multiple AI parts involved within our Track 3D engine as well. Like, you can talk to the system and tell, hey, tell me the progress over the last 6 months for level three of a project. And you will exactly get that, retrieve and visualize. That is another AI. So there are different parts of AI, right, that are involved over here. And what you mentioned is one part of it. The deep learning part of it is just identifying the elements. But it's combination of all this. If sensory fusion and the first 3D reconstruction doesn't exist, downstream everything will not make sense. So there are multiple facets to the entire thing. It is combination of deep learning, it is combination of advanced 3D visualizations, and actually AI working together in different parts. It's the entire pipeline.
Yeah. This is a really good illustration of a point I often like to make where people act as if AI were one thing. And it's just like saying wine is one thing or shoes are one thing. Well, no, there's lots of versions of it, lots of different types, and you don't ever use only one. At one point, this is a lot of years ago, Google had famously had something like 5,000 models in production, and they didn't have 5,000 products. They did what you do, which is you have specialized models and specialized systems to do the thing they're good at, and then they pass it on to your point in a pipeline. Super interesting. Look, man, this has been really. Go ahead, please.
No, absolutely. And these are models, some of them are supervised, some of them are unsupervised. They have to work in tandem, learn from each other, and each component has to be replaceable. Because again, right, there's could be a new advancement over there. You
Yeah.
replace part with the latest version.
Yeah, love it. Well, I love this. This is so interesting in hearing what you guys are up to. And this kind of next phase of progress tracking and spatial AI. NK, thank you for being on the podcast. I loved hearing about this.
Thank you so much, you. It was great fun talking to you. And yeah, thank you.